Alright, so we did pretty good with expanding. That was yesterday's lesson. Today we're going to do the first type of factor, which is common factor. Okay, so get a piece of paper out, pencil. Let's take down the notes. Okay, so again, this is on Brightspace. So if you like to have a handout, you can print it at home. You can copy it down ahead of time if you want. Okay, so common factor. So you can copy down example 1 first. So starting today for the next 4 class, we're going to do different types of factoring. There's only one type of expanding, but there's 4 different types of factoring. So this is the first type, common factor. Okay, so copy this down, copy this example down, and then we'll go through it together. All right, so let's get started. Find the greatest common factor between each pair. So between 6 and 20. To find the greatest common factor, I will have to list out the factors of 6. Okay, so 1 times 6 gives you 6. 2 times 3 gives you 6. So those are the factors of 6. Okay. So what about 20? What times what gives us 20? 1 times 20. What else? Yeah. 2 times 10. What else?
4 times 5.
Yeah, that's it. Okay, notice how I write it. I wrote it like this so that you don't miss any. Okay, looking at these 2 lists, what is the number that is in both? Yep.
2.
Yeah, 1 and 2, but I want the greatest common factor, so I'm going to take the biggest. So in this case, my greatest common factor between 6 and 20, it's 2. All right. So what if I say 6x and 20x? What's the greatest common factor between these 2 terms? Mohammed?
2x.
2x. That's right. Okay, so you look at the coefficient the same way. Okay, I see that it's 2. Both of them have an x, so that means that's also common. What about 4x squared and 3x squared? 3x cubed. Jay? X squared. There's nothing common in 4 and 3. 1 doesn't count. All right, so x squared, x cubed. So that means both of these terms have an x squared. All right, this is xxx. I'm sorry, this is xx. This is xxx. That means from both terms, they both have an x squared. Okay, so what about this one? 12x and 18x cubed. What's common in both terms? Sorry?
3x squared.
Close. There's more other than 3. There's a bigger common factor. 6, right? And how many x?
6x squared.
Does this have an x squared? So this only has 1, so it's just a 6x. That's right. You cannot take a 6x cube out because this only has 1. You can't take 2 more from it if it doesn't have. Okay. So now that we understand common factors, we can apply it to factoring. So factor 15n plus 35n. So factor means I want brackets in my answer. Okay, that's what it means. Factor means I want to see brackets in my final answer. So what is common in each of these terms? I have 2 terms right here. What's common in both terms? Yep.
5.
5, yeah, that's right. So when I take out a factor, I'm dividing it out. That's what I'm doing. So factor means I'm dividing. Okay. A common mistake that people do is they see that, okay, 5 is the common, but then they don't write it out in the final answer. It's just like it disappeared. So make sure whatever you're factoring out or dividing out, you write it first. You write it out. 15m divided by 5, what do you get? 3m, good.
Plus 7n.
Plus 7n, that's right. And that's it. That's your answer. We factored. Hey, your first factoring. That wasn't so bad. All right, then there you go. Yeah, that's what you have to do. That's factoring. I have an answer with brackets. That's good. We're going to do another example. Factor this. So out of these 3 terms, what's common in these 3 terms? 2, yeah. What else? Rosie?
4.
Not just 4. Not 4. Yep, 2 is right because this only has a coefficient 2, so I can't take a 4 out of this term. Yeah, so 2 is correct, but other than the 2, Caitlin?
And cube.
N cube. Yeah, so I can take a 2n cube out of each term. Right? You can think of it as like you have to be fair. You have to take the same thing out of each group. Okay, so what's 2n5 divided by 2n cubed? You get n squared. Good. What about here? 6n. And here?
4.
Okay. Notice it looks really weird. Again, you have to have a plus minus sign to connect the terms. So here, it was plus. And here, minus. Yeah. And that's my answer. I'll give you guys a second to copy example 4. Okay, factor 4n squared p cubed plus 10p4 minus 2np. Yeah, 2 is common again. Good. But not just 2. I can take something out as well. Mohammed? P, yeah. So I can take a 2p out. Okay, so who wants to try telling me the final answer here? Alright, so Jason? Yeah.
2n squared p squared.
2n squared p squared.
5p cubed. N.
Okay. So this is what he told me on the test. I'm going to give this a 1 out of 3. Okay. What's wrong? What's one thing that's wrong? Mohammed? Okay. Yeah. The 2p disappeared. You have to write it at the beginning. Yeah. And then the signs. That's right. So the plus and the minus right here. Okay. So now this is 3 out of 3. Okay. So I could tell like the math was right, but forgot this and forgot those. Okay, so that's good. All right, example 5. Okay, so this is a tricky one. Now, without changing anything, without expanding this out, without anything, just looking at this, how many terms do I have? Jay? 2 terms. That's right. I have this term and I have this term. So looking at just these 2 terms, what's common in these 2 terms? Yep. m plus n. Yeah, so you can take out that m plus n. Doesn't only have to be a number. Doesn't have to be a binomial. It could be a binomial like this. So I can factor out the m plus n. So in my first term right here, what happens to the m plus n's? What happens to these? Cancels. So you're just left with 4x. What about this side? These cancel. So minus y. That's right. And done. That's factoring. I have my brackets. We factored it into two binomials. All right. And because I taught this course for like the 1,000th time, I know when people see this question, they automatically want to do this. All right. Remember, the question was telling you to factor. If I do this, what am I doing? Yeah. Expanding. Yeah. So I don't want to expand. That was yesterday's lesson. The question is asking you to factor, and factor means trying to see what I can factor out of each term. Okay? So don't expand it out. Now, let's say what happened. Let's say you did expand it out. I expanded it out. What would happen? I get 4 terms. Right? So I'll give you guys a second to copy this example down. Example 6. So this is another type of factoring. The first 5 examples is the first type of factoring, which is common factor. And this example is the second type of factoring, called group factoring. Right. So what I did was I expanded it out. And then now I'm stuck with looking at 4 terms. Okay. When you have 4 terms, that's like a big hint that you should do group factoring. So whenever you see 4 terms, you want to do group factoring. Okay. So, is there anything common I can take out of all 4 terms? I cannot take an x because this one doesn't have an x. This one doesn't have an x. Is there anything common in all 4? Alright, so nope, nothing's common in all 4. So what can I do? Factor by grouping. What do you think that means? Right, so Ryan, you got an idea? Right, let's hear your idea.
Factor the first 2.
Yeah, and then?
Factor the other 2 by
Yeah. So that's what grouping means. I can split it up into 2 terms.
You can take common out.
Yeah. So if I just look at these 2 terms, what's common?
2.
The 2. Yeah. So I'm going to take out the 2 in the first 2 terms. So 2x plus y. Okay. What about the second 2 terms? What can I take out in these 2 terms? What's common in these 2? Equal? M. So then plus m, and then x plus y. Right? I factor out the m, and what's left? X plus y. Huh. Now doesn't this look like example 5 now?
X plus y bracket 2 plus m.
Perfect. That's right. So now I have my 2 terms, and x plus y is the common factor between these 2 terms. So when I factor it, I get the x plus y, which is what I'm factoring out. And what's left? That cancels. So I'm just left with 2. That cancels. I'm just left with plus m. So in example 5, if you really did expand it out and you get 4 terms, you could still end up getting the answer, but you just went in a big circle. Okay. Remember, anything that you expand, you can also factor back. So it's just a matter of steps. Okay. Try this one. So again, I see 4 terms. Hint, hint, hint. I should probably do group factoring then. First 2 terms, what can I take out?
3x.
Good. Alright. So for the first 2 terms, when I take out that 3x, I have 3x, bracket
2x minus x.
2x minus... What's 3x divided by 3x? Yeah. Nope, just 1. Yeah, so 3x divided by 3x is 1, so you have the 1 here. Not yet. Okay. And then here, what can you factor out of these 2 terms?
2.
2. Okay. If I factor out the 2 right here, what's negative 4x divided by 2?
2x.
Negative 4x divided by 2? Negative 2x, right? But I don't want negative 2x. I want it to match up with this side. So instead of just taking out that 2, I can divide both sides by a negative 2. So now what happens when I do negative 4x divided by negative 2? I get the positive 2x. And positive 2 divided by negative 2, I get negative 1. Now both brackets match up.
Is that mandatory?
Because if you don't do that, you're going to get negative 2x plus 1. And I don't see the same factor. Yeah, so the signs matter. The signs do matter. You need the 2 to be exactly the same in order to take the common factor out. Okay, so this. So now that means out of these 2 terms, I can take a 2x minus 1 out. I can take a 2x minus 1 out of this. I can take a 2x minus 1 out of this. So what's my final answer? Who wants to try telling me the final? Put up your hand. Rosie.
Bracket 2x minus 1 bracket 3x.
3x
Oh, minus 2.
minus 2. Perfect. Okay. Again, the signs is what most people get wrong on. The signs. So be very careful with the signs. Okay, last example. This one. I want you guys to try it. Okay, I see 4 terms. So I should do group factoring. Split these 2 into 2 parts. Okay, so I'm going to write down my answer. And then I'm going to see if you guys get the same thing. Okay, who has an answer for me? Hey, okay, Miriam.
Minus, I divide by 3x,
Mm-hmm.
and then divide by -1.
Okay.
And you get 3x times x minus 1 in brackets.
Yep.
And you get -1 times x minus 1 in brackets.
Perfect. Then the -1 here was the trick. So looking at these two terms, there's nothing common, but 1 is still common between them. 1 is common in everything, in anything. So then Miriam took that -1 out because she wanted the positive x right here. And so your final answer?
It's x minus 1 in brackets times 3x minus 1 in brackets.
Perfect. How many of you got that? Awesome. Okay, so see, the factoring was not that bad. Now, let's say I'm not sure. I don't know if I made this, I don't know if I did this correctly. What can I do? What can I do to check my answer? What can I do to check if I got it correct, if I factored it correct, Mohammed?
Expand.
Yeah, expand, what we did yesterday. FOIL, do FOIL out, and you should get this. So you can finish the test and do the opposite of every question. See if you get the answer. If you get back to the original question, you know you did it correctly, and you could come out of the test knowing you got perfect before I even mark it. Okay, and that would be very good because then marking would be very much easier for me. Okay, so all of these you can expand this back out and see if you get the original. All right, good job. So that's the lesson. You guys did factoring. These are the questions I want you guys to work on. It's on Brightspace. If you don't write this down, you're doing every single question from 1 to 13. All right, otherwise, just do 1, 4 to 6, 8, 11, and 13. Okay, you guys have the rest of the class a good half an hour to work on these. So 1, 4 to 6, 8, 11, 13. And I'll add you to Brightspace so that you can access this. Thank you, sir.
I don't really know how to do this page, so
It's okay. At least you tried. Okay, thank you. And make sure I get that note.
Can I ask a question about
Sure. All right. So here's the questions on Brightspace. So 1, not 2, not 3, 4. What did I say?
4 to 6?
4 to 6. Yeah, 4 to 6. Not 7, and so forth. Yeah. And so next time, don't ask during the lesson because you know I'm gonna say no. Okay, so these questions right here is on Brightspace. I'll leave this up.